Hello everyone, and welcome to Eco Canada's latest webinar, Fundamentals of Greenhouse Gas Management. There is growing international concern about climate change and about how we can mitigate its harmful impacts. Quantifying greenhouse gases both emitted and removed from the atmosphere is a powerful tool in the fight against climate change. Today's guest speaker is going to talk to us about an overview of really the fundamentals of how we start to quantify and manage greenhouse gases. Before we start, I just have a few housekeeping points that I want to run through. My name is Hannah Williamson and I'm the Training and Events Coordinator here at Eco Canada. Today's presentation is pre-recorded, so if you do have questions about the content or for our guest speaker, you can send them to events@eco.ca. And this recording, along with many others, is available through the Eco Canada website. Please visit www.eco.ca to find out more about our range of webinars. Today's webinar is brought to you by Eco Canada. ECO is a steward for the Canadian environmental workforce across all industries and sectors. From job creation to wage funding to training and labour market research, we champion the end-to-end career development of an environmental professional. Our aim is to promote and drive sustainable economic growth whilst ensuring that environmental care and best practice is always a priority. Now, without further ado, I'm going to introduce our guest speaker today. Andre Morin from Enviro Access holds a bachelor's degree in mechanical engineering as well as a master's degree in business administration. Andre has worked in several different fields throughout his career. He was a project manager for a large consulting engineering firm for 7 years, serving a diverse range of clients. He also has a certified lead APBD+C, carrying out several energy efficiency projects. Andre uses his creativity to bring innovative solutions to each and every customer, never leaving a problem unsolved. After his MBA, he gained experience as a manager in a context of complex change within the public service, in addition to obtaining his Lean Six Sigma Black Belt certification. Welcome, Andre. We're so pleased that you can join us today.
Thank you, Anna, and hello everyone. Welcome to today's presentation. As Anna mentioned, this is a pre-recorded webinar, so if you have any questions, please feel free to send them up by email, and we'll get back to you as soon as possible. Also, today we will be going through a general overview of many topics, which could be the object of specific trainings by themselves. And here's today's agenda. So we'll begin with the presentation of our organization, Enviro Access, then follow with an introduction to the greenhouse gas science, so looking at the greenhouse effect and its links to climate change. These will be followed by a discussion on GHG quantification, so why quantify your GHGs and how. To answer these questions, we'll review the applicable international standard and address certain specific elements such as GHG project and carbon market. Finally, we will end the presentation with an overview of the concept of validation and verification. Enviro Access was founded in 1993. It provides professional and technical services to businesses and institutions to help improve environmental quality and promote sustainable development. More specifically, since 2005, the team has focused on the greenhouse gas emissions sector and is now among the most experienced organizations in this field in Canada. The clients served are mainly private companies, but also include several cities and municipalities, as well as various government agencies and organizations across the country. We offer two categories of services, and the first being the consulting services, ranging from GHG emission inventories to reduction action plans through the project emission reduction identification and quantification, up to product carbon footprint analysis. We have developed our own Carbon Care certification, which aims at recognizing organizations that are proactive in managing their GHG emissions. The second category is the carbon audit services, and by that I mean verification and validation services. It is interesting to mention that we are one of the first organizations in Canada to have been accredited in 2011 as a validation and verification body for GHG emissions. This was granted to us by the Standards Council of Canada, SDTC, which also monitors all our activities in this area through annual audit and witness audit when carrying out certain mandates. And now getting down to business with the greenhouse gases science. As you probably know, our planet is a system in equilibrium between its four main components: the atmosphere, hydrosphere, lithosphere, and biosphere. This principle of balance is illustrated in the figure shown here. The atmosphere represents the gaseous layer surrounding the planet. The hydrosphere includes each and every water reservoir. The lithosphere represents the outer layer of the Earth's crust, while the biosphere includes all living things inhabiting the planet. The atmosphere's composition is very variable both temporally and geographically. It is also made up of several different types of substances. Except for water vapor, these substances represent less than 1% of the total air volume on a dry basis. Due to their low percentage, these substances are presented in parts per million, ppm, or parts per billion, ppb. The table shown here allows you to visualize some elements that make up for this 1%, namely water vapor, carbon dioxide, CO2, methane, CH4, nitrous oxide, N2O, ozone, O3, materials, particulates, and chlorofluorocarbons, CFCs. All these elements, among others, make up the atmosphere and play a very important role in the phenomenon we know as greenhouse effect. But precisely what is that phenomenon? Let's take a closer look. Earth receives solar radiation on its surface throughout the year. The intensity of this radiation is, as we said, variable in time and space. It varies according to the Earth's rotations around the Sun, but also according to where you are on the planet. The graph below shows the variation in the energy received as a function of the latitude on the globe. So the Sun's energy that we receive has a small wavelength and is mostly in the visible spectrum. However, the Earth also emits radiation, but this obviously does not have the same amount of energy as a solar radiation. In fact, the Earth emits the energy absorbed from the Sun in the infrared ray spectrum, therefore at a long wavelength, as can be seen on the images here. Here we see on the left side that the thermal state of the Earth's atmosphere system is relatively stable. That is, it is not subject to any lasting heating or cooling effect. There must therefore be, as an overall average and during a sufficiently long period, such as a few years, a balance between the absorbed solar radiation, which heats the Earth, and the radiated heat outgoing infrared radiation, which cools it. The radiative balance are net radiation of the planet, which corresponds to the difference between the solar radiation absorbed and the terrestrial radiation emitted into space, must therefore be equal to 0. This makes it possible to have a system in equilibrium. On the right side, we see that the greenhouse effect is a fundamental element of this system in equilibrium. In fact, due to the presence of certain types of gases in our atmosphere's composition, some of Earth's radiation is reflected back to the surface or absorbed by the atmosphere. This helps conserve some of the thermal energy that would otherwise have been re-emitted into space. This phenomenon is the reason why we have life as we currently know it on Earth. Thanks to the greenhouse effect, the average Earth's temperature is plus 15 degrees Celsius. Without this precious phenomenon, the latter would be rather a freezing minus 18 degrees Celsius. So these gases, which absorb terrestrial radiation, are known as the greenhouse gases, or GHGs. Their contribution to the greenhouse effect varies depending on their composition. The table on the right here lists the main GHGs and their contribution to the greenhouse effect. It is thus possible to see that, surprisingly, it is not the carbon dioxide that has the top of the list, but H2O, yes, water particles. The list also contains methane, CFC, nitrous oxide, and ground-level ozone. The diagram here summarizes the concept presented previously. It is possible to see the whole system in equilibrium, so the energy received, emitted, absorbed, and reflected, with the GHG roles in it highlighted by the red circle. We have previously seen that the contribution of gas to the greenhouse effect varies according to its composition, so in the GHG vocabulary, this principle is called global warming potential, or GWP. The GWP of a GHG describes the radiative forcing impact of a given gas mass unit relative to an equivalent unit of carbon dioxide, CO2, for a given period that is usually about 100 years. In other words, assuming that carbon dioxide represents a global warming potential of 1, each GHG is evaluated to determine how many molecules of carbon dioxide it would take to equal the global warming potential of that GHG. For example, since the methane's global warming potential was estimated at 28 according to the latest Intergovernmental Panel on Climate Change, or IPCC, report, we would need 28 tons of carbon dioxide to equal the global warming potential of methane. As shown in the picture here, the value obtained following this transformation is presented in carbon dioxide equivalent. We have seen in previous slides that the Earth system is in equilibrium and that the greenhouse effect is not only desirable but essential to life as we currently know it on Earth. But why then talk about climate change, and why is the greenhouse effect currently being singled out as the cause of them? Well, the key word to remember here in order to fully understand the phenomenon is the word equilibrium or balance. Indeed, the radiative balance we have spoken of is what allows the Earth to maintain its average surface temperature of plus 15 degrees Celsius and is currently in serious danger. Why? Well, the answer lies in our atmosphere's greenhouse gas concentration. Since the industrial era, it is indeed possible to observe that the GHG's concentration in the atmosphere is growing exponentially. It is easy to see from this graph that the carbon dioxide concentration in the atmosphere is currently experiencing a peak that has never been so high in the last 800,000 years. Our atmosphere currently contains a concentration of around 415 ppm of carbon dioxide, a far cry from the highest historical value found on Earth, which is about 300 ppm. And this dazzling increase has only occurred in the last century. The problem is caused as much by the carbon dioxide as by other GHGs. What is even more worrying is that not only is the atmosphere's GHG concentration increasing at lightning speed, but above all, it is that the average Earth's temperature is following the exact same trend. As can be seen from these two graphs, we are currently experiencing a runaway average temperature. But why? What has changed so much in the last century to have such a marked effect on the Earth's balance? Humans have been present on Earth for millennia. How come suddenly our presence creates such a deep problem? Well, the villains in this story are not necessarily the humans, but the fossil fuel that humans use in all their activities. Oil, natural gas, gasoline, diesel, propane, etc. are all carbon-based fuels. Their combustion emits carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O, into the atmosphere that were not naturally predicted in the Earth's equilibrium we saw previously. Rather, this carbon should have remained sequestered in the soil for millions of years to come and only be released into the atmosphere very gradually. This sudden release of fossil carbon completely disrupts the radiation balance of the planet and the equilibrium it has known until now. So what exactly are the effects of this disequilibrium? Is it possible and justified to directly link natural disaster to this climate change? Well, the Earth system is extremely complex and involves innumerable factors and interactions. As such, it is unfortunately not possible to directly relate such natural disaster to the increase in average temperatures, for example. However, it is possible to predict certain trends and general consequences of this disorder. Some examples would be an increase in precipitation in some areas and drought in others, ocean acidification and increase in temperature, augmented frequencies of extreme weather events such as we've seen on the last slide, up to biodiversity loss. This is only a part of the consequences of climate change. NASA has created a comprehensive website on the subject, which I invite you to consult using the link shown here. The intensity and frequency of these consequences will be directly related to the magnitude of the average temperature's increase. Currently, Earth's average temperature has increased by 0.9 degrees Celsius since the early 19th century. If the trend continues, this average will only increase. And if nothing is quickly done to limit the GHG emissions, the IPCC predicts an increase in the average global temperature of 5.5 degrees Celsius by the beginning of the 22nd century compared to the pre-industrial era. Knowing that at 0.9 degrees Celsius we already know countless negative and often irreversible effects on biodiversity and the environment, an increase of 5.5 degrees Celsius would be catastrophic not only for our planet but for us as an integral part of this fragile system. Now that we have discussed climate change and its causes, let's continue our program to discuss the GHG emissions quantification. Please keep in mind that this webinar is only an overview of the training in preparation by Eco-Canada about GHGs. So, if you'd like to dig deeper into the topics discussed here, Stay tuned for what's coming up with Eco-Canada. So, why quantify your GHG emissions? In some contexts, reporting an organization's GHG emissions will be required to meet a regulation. Companies will have to produce a GHG emission statement based on certain parameters, much like a tax report. It will depend on their location, province, or territory and the company's activities. Also, maybe your organization is part of an international company that is subject to head office country regulation. These would still require you to report your GHG emissions anyway, even if you yourself are not required by the laws and regulations of your current location. It is also important to note the subtlety between a GHG statement and a GHG inventory. In fact, an inventory can also be referred as a GHG statement, but on the other hand, a GHG statement is not necessarily a GHG inventory. Here are some examples of mandatory reporting programs across Canada that have been put in place to reduce GHG emissions from industrial companies. Whether it's Alberta, British Columbia, Ontario, Nova Scotia, or Quebec, these provinces have specific regulations that require different types of organizations to produce annual GHG emissions reports. Otherwise, for provinces and territories that do not have one, the federal government has different programs, such as the recently imposed Greenhouse Gas Reporting Program, GHGRP, or the Output-Based Pricing Systems, most commonly known as OBPS. These different programs all have one thing in common, a reporting threshold. We were saying that the regulations are based on a minimum threshold above which the company must report its emissions. Well, this threshold is often found at 10,000 tons or 10 kilotons of annual emissions, with a few exceptions, such as fuel distributors who are required to produce one even if they don't meet the reporting threshold. Otherwise, organizations who opt for a voluntary approach will often do so to express their desire to do more for the environment and thus demonstrate their commitment to sustainable development. This is therefore done by participating in so-called voluntary initiatives or programs. These can aim for carbon neutrality by offsetting emissions or reducing them as much as possible to tend towards the zero-emission target. Ultimately, if the objectives of the program or initiatives are met, a form of recognition can be obtained. These voluntary programs can lead to a recognition that will improve the company's brand image, and there are also several possible recognition in different areas. For example, we can look at certain eco-labels that are related to GHG reductions or to demonstrate adaptation to climate change. Pay good attention to the notoriety of the certifications. As there are several of them, you should educate yourself in order to choose one that is recognized and that will really bring the desired notoriety. Actions can also be taken to stand out amongst investors or stakeholders such as employees. For example, GHG reduction initiatives can enhance employees' engagement toward the company. There are also several sectoral or internationally recognized programs available, such as the Carbon Disclosure Project, which is recognized globally, or something much more specific like the International Civilian Aviation Organization's CORSIA program related to airlines. Enviro Access has its own Carbon Care certification. We can grant it to an organization that carries out the GHG emission inventory with the International Standard Organization 14064 Part 1 standard, and that clearly demonstrated its commitment to reducing its GHGs. This leads to what we call the first level of Carbon Care certification. There are around 65 companies and organizations that have obtained this certification, and about 20 more that have reached the second level by offsetting their emissions, thus obtaining the Carbon Care Compensated Emissions certification. Another example of a well-known sectorial initiative across the country is the Partners for Climate Protection program from the Federation Canadian of Municipalities. According to the UN Climate Action website, cities consume about 78% of the world's energy and produce more than 60% of greenhouse gas emission. This is not negligible. Further training should also be given on GHG inventories for cities and municipalities, so stay tuned to Eco-Canada. We've seen that there are good reasons to quantify your emissions, so once convinced, let's see how to quantify them. But first, to ensure uniformity, an international standard has been designed and prepared by the International Standard Organization. This standard, which bears the number 14,064, serves as a reference or guide for those who wish to carry out a GHG inventory, a GHG project, or a GHG validation verification. The standard is divided into 3 parts, each dealing with a specific theme. The Part 1 covers GHG inventories and includes guidelines for quantification and reporting at the organizational level. The Part 2 covers GHG reduction project and gives guidelines to help not only quantification, but monitoring the project as well as structuring a baseline scenario comparison. Finally, the Part 3 covers the validation and verification process specifically. This part will normally be used by verification bodies such as RDOCECA since the guidelines aim at structuring the declarations examination process. The 1464th standard is part of a series of interrelated standards. This diagram allows us to see the relationship between each subpart of the standard and other GHG-related standards. On the top part, we find the 14,064 Part 1 and Part 2 standard as well as the 14,067 standard. They each dictate rules concerning respectively GHG quantification for an inventory, a project, and a product carbon footprint. These standards are guidelines that apply to the preparation of a GHG statement. Then the 14,064 Part 3 standard will be used to verify the GHG declarations. Then the 14,065 standard dictates the requirements for verification and validation bodies such as us, RDOCECA. And finally, the 14,066 standard gives the competency requirements for verification and validation teams. But why use a standard to quantify GHGs? Well, first it improves the quantification procedure quality and consistency. This structure in turn improves the GHG report credibility and facilitates the implementation of GHG reduction management and monitoring projects. Finally, it will facilitate the allocation of carbon credits and their trade, since their calculation is standardized. The 14,064 Part 1 standard is used to do GHG inventories. It has strict requirements for information management, document archiving, record keeping, etc. Overall, the standard structures the completion steps to prepare a GHG emissions statement at the organizational level, or what is often referred to as a GHG inventory. This initially consists in the definition of the organizational and operational boundaries in relation to the different sources and what we will consider as emissions. The second step is to choose a reference year. If this is the first time that an inventory is calculated, this will be the base year. Otherwise, it is either the first year in which an inventory has been made or another that will have been determined to compare the emissions evolution and see if there is a reduction or an increase. Once the base year is determined, the quantification method is then chosen and the required data outlined. The purpose is to identify what we need to accomplish the quantification and how we are going to get the necessary information. The plan can be carried out when completed. After the data collection activity is done, we can select the emission factors to eventually calculate the net emissions or removal. Inventories are great for measuring, but we will often follow them with the definition of a reduction target and a reduction action plan. These latter parts will be covered in another training. The 14,064 Part 1 standard refers to 5 basic principles, which are relevance, completeness, consistency, accuracy, and transparency. The first principle, relevance, requires you to select GHG sources, either emissions or absorptions, related to your needs and situation. The second one, completeness, requires you to document every significant sources or reservoirs to ensure that nothing was left aside. You might have to justify why you chose to include or exclude the source. The third one, consistency, implies, for example, that you have to use as much as possible the same methodology for your similar GHG emission sources calculations. This is especially important if you are comparing results from different years as, for example, again, some emission factors or calculation methods may have changed. Calculations from previous year would then need to be redone to ensure consistency and allow a proper comparison. The fourth principle, accuracy, aims at reducing uncertainties by encouraging the use of data with a high level of confidence. There is always the concern of cost versus precision, so that needs to be thought through. Lastly, for transparency, there must be sufficient information about the data used for calculation. It must be easy for anyone to trace the origin of the numbers or reference used. Right now, we are in a transition period from the 2006 standard to the 2018 version standard. The 2006 version calls for the GHG emissions to be categorized into direct emissions, indirect emissions related to energy, and other indirect emissions. Since the 2018 standard update, the other indirect emissions are now divided into 4 other scopes, which are indirect emissions due to transport, indirect emissions due to product use, indirect emissions associated with the use of products, and the indirect emissions from other sources. The last scopes that used to be merged are the other indirect emissions, and they include pretty much everything else. Some GHG programs will specify some or all of these scopes to include in a quantification. For example, employees' transportation is included in Scope 3, and this includes daily transportation or business trips. The Scope 4, indirect emissions from products used by the organization, can include the product transportation from supplier to your plant by a delivery company, the decomposition of a reduced. Scope 2 is related to energy indirect GHG emissions. It includes indirect emissions from the production of imported electricity, heat, or steam for the organization's use. These energies are supplied by sources outside the organizational boundaries. The most common one is the use of electricity, since there are very few organizations that produce their own electricity. You can guess that there will be a significant difference between hydroelectricity and coal-generated electricity. The last scopes that used to be merged are the other indirect emissions, and they include pretty much everything else. Some GHG programs will specify some or all of these scopes to be included in a quantification. For example, employees' transportation is included in Scope 3, and this includes as well daily transportation and business trips. The Scope 4, indirect emissions from products used by the organization, can include the product transportation from the supplier to your plant by a delivery company, the decomposition of residual materials in landfill, or the emissions that occur at the raw material production stage. Scope 5 emissions, which are the ones associated with the use of the organization's products, includes emissions occurring during and at the end of the lifespan of your product. Any other kind of emissions that do not fit the described scope will be included in the Scope 6, indirect emissions from other sources. The diagram here illustrates each of the different emissions categories to which the 2018 standard refers and contains the 5 emissions categories. The green arrow in the middle shows the example of direct emission sources, while the orange arrow on the left shows possible origins of energy indirect emissions. Finally, the blue arrow on the right allows you to see other indirect emission sources, such as we discussed previously. This picture represents another graphic visualization of emission scope that can be found in a typical inventory. Everything that is located inside the middle box is under the organization's control. It is here represented under 2 main categories, which are buildings and vehicle fleet. This implies that the organization could implement different actions to reduce GHG emissions for each of these sources. Take note that the energy indirect emissions are regrouped in the top left box, since the energy consumed by every building can be collected in one category. You can also see different examples of the other scopes according to their definition. Let's do a quick GHG emissions quantification example together to show you how it's done. Keep in mind that every part of GHG quantification could be covered in much more detail in the subsequent training available from EcoCanada. Let's suppose we have a building that uses natural gas to heat its premises. To obtain the GHG emissions associated with this activity, we will use the amount of gas consumed in a year and multiply it by the various emission factors associated with the combustion of natural gas. As explained earlier, the natural gas combustion will produce carbon dioxide, methane, and nitrous oxide emissions. To obtain the total emissions from this source, we will use emission factors for each of these GHGs, which can be found in the Canadian National Inventory Report, or NIR. We have listed them here in the middle table. We will also have to use the global warming potentials of these gases to convert them into carbon dioxide equivalent, and these factors are listed in the right table. So, Assuming that the annual consumption of natural gas is 5 million cubic meters, we can determine the total emissions by multiplying that number by each emission factors. This calculation therefore gives us emission in kilograms of CO2, CH4, and N2O. To convert all this to carbon dioxide, we simply need to multiply these methane and nitrous oxide emissions by their associated global warming potential and add them up. This gives us a total of 9,487 tons of CO2 equivalent per year. In this example, we have used emission factors associated with the combustion of natural gas from the Canadian GHG inventory. However, there are many different sources of emission factors. For example, provincial regulations often use their own emission factors. It is also important to mention that the 14064 standard requires you to present the results of your calculation first by type of GHG and then in ton of CO2 equivalent, exactly as we did in the example. It is therefore important to use emission factors by type of gas when they are available. If these cannot be found, it is always possible to use an overall carbon dioxide equivalent emission factor directly. Now that we have explained the first part of the standard, let's talk a bit about the second part. This will normally be used for the quantification of GHG reduction project. There can be many reasons to undertake a GHG reduction project. A company may want, for example, to highlight its social responsibility or its corporate image, mobilize its stakeholders such as employees around a common project, become carbon neutral, reduce its emissions to comply with regulations, or participate in a carbon market. Also, there are often interesting monetary benefits from a GHG reduction project since it often increases energy conservation and efficiency, thus improving the company's profitability. So up to now, we've been talking a lot about GHG reduction projects. So precisely what are they? It's a specific activity designed to reduce GHG impact by reducing either GHG emissions or increase their absorption. It implies the need to set a hypothetical reference scenario against which the project impact will be compared. This reference is called baseline scenario. The graph below illustrates this concept by presenting the baseline scenario emissions and comparing them to the project's emission itself. The difference between the two represents the GHG reduction. As an example of GHG reduction, we can think of the emissions reduction linked to the conversion of a heat source running on fossil fuels to a source using renewable energy. As for absorption, they are often best represented by the carbon sequestration of trees. A project could therefore involve the planting of trees and thus reduce GHGs through these absorption. The choice of baseline scenario must be made with consideration in order to represent the most likely conditions that would have been present in the absence of the GHG project. We must therefore make realistic assumptions. The graph here illustrates the reductions depending on the reference scenario chosen, R1, 2, or 3, compared to the project below. Thus, to determine the GHG reduction generated by a project implementation, two quantifications must be made, namely the quantification of the project-related emissions and the reference scenario-related emissions. We can then compare them to get the reduction. So on the graph below, we would compare the R2 curve to the project curve. When we think of GHG project, we often think of the carbon market. So how does it work? Well, in its regulated version, a carbon market is a political tool aimed at reducing GHGs. It is also a trading mechanism for GHG emissions right, carbon credit, and carbon quotas. Its goal is to force large emitters to reduce their GHG emissions, but also to stimulate the clean technologies development. You can see on the image that basically, a large emitter that exceeds the threshold will have or be able to buy credits to compensate its emissions. These credits will be bought from another company that has emissions below that threshold and is willing to sell its credits. There are two types of markets, the regulated market and voluntary market. Comparing both markets, a voluntary carbon market offers offset credits that can be used by companies, governments, NPOs, NGOs, and individuals on a voluntary basis to compensate their GHG emissions. Some examples include the Verified Carbon Standard, Gold Standard, and Canadian Standard Association. There really are no requirements or regulation for an organization to participate in this type of market as an acquirer, but as we have seen, there can be very interesting benefits. Regulated markets are set in place by governments for companies falling under legal obligations to control their GHG emissions. It has a similar emissions trading and possible use of offsets to meet reduction targets. Examples include the European Union emissions trading system, Ontario's output-based pricing system, and Quebec's cap-and-trade system. To participate in those markets, it is most of the time necessary to have your GHG declaration validated and verified. The 14064 Part 3 standard precisely dictates the requirement for validation and verification activities. It specifies the general requirements to be met in a validation verification process and gives the explanation on the different steps to be followed. The first step concerns the pre-engagement activities, and they are done before undertaking the audit and include, amongst others, the impartiality analysis, the definition of the audit scope, the level of assurance, and the definition of the materiality threshold. Next, we must select the validation verification team members, taking care to identify the people who have the appropriate skills. This is followed by the planning for the audit, which is done through activities such as risk management, the evidence collection plan development, and the audit plan development. Sometimes the verification team will need to go on site and confirm the GHG statement contents. So before carrying out this visit, there must be a visit plan established to ensure the correct evidence collection methodology. When all the plans are completed, well, we execute them, and the evidence gathering activity is the crucial step in this part. Once the collection is completed, the team must analyze all the information collected and assess all elements of the GHG declaration against the applicable validation and verification criteria. Any difference from the requirements must be raised, and those that lead to significant issues must be corrected for the validation verification conclusion to be positive. Also, the sufficiencies of evidence should be assessed, and the changes from previous periods should be taken into account. Finally, the team must draw a conclusion and write an opinion in a validation and verification report. This report and all steps in the process will be submitted to an independent review carried out by another person who was not involved in the validation and verification process. This is intended to provide an independent look at the quality and compliance of the work performed by the verification and validation teams. Finally, once the independent review is complete, an opinion will be issued. This opinion can be unmodified, modified, or adverse, depending on the absence or presence of nonconformities and their seriousness. Evidence gathering is really a critical part of a verification. The verification body needs to confirm data source to have the best possible confidence in the data itself. It will also have an impact on materiality assessment. As for risk analysis, there are 18 factors to consider for the risk assessment, and they are all included in section 6.1.2 of the standard. There is an important distinction to be made between validation and verification. First off, a verification takes place after a project implementation. It is the core part of the process that confirms to program authorities that the GHG declaration meets the verification criteria and level of assurance, and, in the case of a project, that the proponent is adhering to its project plan. A validation covers the project plan. It is accomplished before a project's admission to a program and before the project implementation. Generally, validation helps ensure, for example, the eligibility of the project compliance with quantification methodology and proposed monitoring protocols. So this concludes our overview of the different elements that are part of the GHG management sector. Obviously, what we have seen today only cover a tiny part of the whole topic, so if you want to learn more, stay tuned for future training offered by EcoCanada. And for a closing remark, we have seen today that GHG emissions quantification at the organizational or project level is a serious and standardized scientific process. A certain level of knowledge is required to properly carry out these activities in compliance with the applicable standard. Fortunately, EcoCanada is developing several training courses to help you take these steps. Funding programs are available from government to carry out GHG emissions inventories or to finance reduction activities. And finally, Considering GHG emission is an effective way to raise awareness of the impacts of human activities on the environment and thus encourage action to help limit the planet's global warming. Thank you very much for your interest, and I hope you've learned something today. Once again, stay tuned for upcoming trainings from Eco-Canada. Also, let me remind you that Enviro Access has a team of experts that can assist you with your needs beyond training, so feel free to contact us. Again, thank you and have a good day.